This equation right here is pretty long. It's got quite a bit going on with it. It has multiple sets of grouping symbols, but just because it's got a lot going on doesn't mean we're going to treat it any differently than any other equation. We still start with our grouping symbols and we work our way down. So when we look at our grouping symbols, it looks like the first thing that we can do is we can do this 2 multiplied by 5. We've got 2 multiplied by 5 inside parentheses. That's going to give us 10. So let's go ahead and start off with that. So that'll give us 10 minus 8 in that first set of parentheses. That next set of grouping symbols has got 3h plus 6 in it, and there's not anything in there that we can combine. 3h and plus 6 are not like terms, so let's leave those separate. Then we've got a bracket followed by 2h plus h, and 2h plus h are like terms, so let's go ahead and combine those. 2h plus h is going to give us 3h, and that's the entirety of that set of parentheses, so we don't need those parentheses anymore after we do 3h. So let's do 3h plus 6, and then we've got that 2 on the end. Okay, great. So what can we do next? Well, the 10 minus 8 can be subtracted. Those are like terms, so that'll give us a 2. And once we do 10 minus 8, we don't need the parentheses anymore. We got that 3h plus 6 next equals. And then I'm going to go ahead and just so it looks the same, I'm going to move this 2 in front here. And I'm allowed to do that. If it's multiplication, I'm allowed to change the order. So let's put the 2 in front of these grouping symbols here, and that'll give us 3h plus 6. And now we've got distributive property going on both sides here. So let's go ahead and distribute. So we've got 2 times 3h gives us 6h. And then 2 times 6 is going to give us 12. And then over on the other side, let's switch colors here. 2 times 3h gives us 6h. And 2 times 6 gives us 12. And so what we end up with is 6h plus 12 on the left side and the right side. The two sides of this equation are exactly the same. What this means is no matter what we substitute in place of h, no matter what value of h we use, the left side is always going to be equal to the right side. Any value of h will work here. So any real number could be a solution. So we say that our solution here is all real numbers. This has infinite solutions. Infinite solutions because any number will work. And an equation that is true for every value, an equation that is true for every value of the variable is called an identity. An identity is the name of an equation that is true for every value of a variable, an identity. And so that's what we have here. We have an identity because since both sides of the equation are exactly the same, no matter what value we plug into h, both sides of this equation are going to be equal.